All right, in this video we're going to look at absolute value equations. So before we get into this, we need to look at some real basic ones here, just so we can sort out why things are going to happen the way they are, when we should be concerned, when something just doesn't look right? Because there's a lot of hidden kind of complications that go on with absolute values. They almost look simpler than meets the eye. So to help make sense of this, right, we're also going to look at some graphs. But let's think about this. We know that an absolute value takes the value that's inside and it makes it positive. That's what a lot of people like to say. It makes it positive, right? So basically, we can just pick an x that we know is going to have a 4 out, right? I mean, we can say that if we plug in a 4, absolute value of 4 is 4. So x being equal to 4 would be a solution here. But since an absolute value makes a number positive, that means if we plugged in a negative 4, then the absolute value of negative 4 would also be 4. So negative 4 also works here, right? Now in this case, remember we can pick whatever we want, but this thing is going to make the number that I choose become positive. So even if I put in a negative 4, that's going to spit out a positive 4, which is not going to give me a negative number, right? I mean, if I selected whatever x I wanted, the smallest possible outcome I could get is 0, right? Because the absolute value of 0 is 0. But once I go with negative numbers, it's going to turn them upward to positive. So there's not going to be any way for me to select an x that's going to produce a negative output, right? So this guy actually has no solutions here, right? Whereas this one actually had two different solutions. So let's look at this visually, and then let's try to come up with a method for solving these as we move along. So we know that an absolute value equation, right, can be solved, but as a graph, an absolute value function is going to be a v, right? And what we were looking for is, if we consider this like two different functions, right? I want to see where the absolute value is actually equal to 4. So if this is f of x and this is g of x, right? The f of x is the v, g of x, y equals 4 is just a horizontal line at 4. So I'm finding the x that satisfies both of these sides simultaneously, right? I want the x that makes this a true statement. So you can see that if I come back here to x equals negative 4, it's actually going to work for both of them. And if x equals positive 4, it's going to work for both of them. So positive 4 and negative 4 were both solutions, right? If I looked at this v and negative 4 as a y is down here, we can kind of see that the absolute value will never get low enough to produce that negative output. So there's not going to be any solutions here, right? So this is going to be something that we got to keep an eye out for, right? Because we know that whatever's inside the absolute value, that value can either be the positive version or the negative version of what we want it to be, right? This is how we're going to approach this. If we want an output of 4, then that means x, right? X can either be the positive version of our output, 4, or the negative version of our output, negative 4. So in its most basic form, the thing inside can be the positive and negative version of what it is that we want. So if we translate that to here, you can say, okay, well, the thing that's inside is either equal to the positive version or the negative version here. So x should also be either 4 or negative 4, right? So in the process, if you just glaze over the idea that absolute values cannot produce negative outputs, then you're just going to go through the motions and find x's, and there's really no need to check our answers as long as we connect these logical outputs from the absolute value in our mind. Right? If you're not sure if you did it right, of course you can, take these answers and plug them in and see if they work. Right? But that's not actually completely necessary if we can sort out what's supposed to happen and what can't happen. Okay? So, I know that sounds like a lot of talk, but let's give one a try. Okay. So, solving these is going to be a lot like solving like square root functions, where in order to determine what kind of outputs we can get from the absolute value, it would be nice to know what the absolute value needs to be as an outcome. And this 2 on the same side of the absolute value kind of makes it hard to imagine what kind of values can come out of this. So what we're going to do is we're going to get the absolute value expression alone, and then we'll deal with how the absolute value affects the expression inside. So in order to get him alone, I do not want the 2 here. Right, so I'm going to get rid of the 2 by subtracting, right? Okay. So I got my absolute value. I don't really care what's inside, right? I'm going to deal with that here in a minute. 9 minus 2 is 7, right? Okay, so now that the absolute value is alone, we need to consider what can possibly happen. Now we know that the absolute value will take the expression inside, right? It will take the expression inside and turn it into a positive. So we have 2 possible things that can happen. The thing that's inside could either equal 7, or the thing that's inside could either equal negative 7. So to remove the absolute value, we're going to split this equation into those 2 logical options, right? The thing that's inside, right? Don't change it. You don't change the negative to a positive because it's an absolute value. The expression inside, which is x minus 5, if it's equal to the positive 7, then that means if this guy is equal to 7, the absolute value of 7 is 7. That's true, right? Or the thing that's inside can be equal to the negative version, because if the x minus 5 were equal to negative 7, then the absolute value of negative 7 would also be 7. That would also be true. So splitting this equation into these 2 options is going to be how we remove the absolute value, so to speak. Now we're going to solve these like we normally would. If I add 5 to both sides, I get x equals, what, 7 plus 5 is 12? Or negative 7 plus 5 is negative 2, right? Now, we know that an absolute value can equal a positive, so when I split and remove, these guys should be my answer. I know logically this is working, so I shouldn't have to check them. But if you're paranoid or you think you make mistakes a lot, you might want to just check them, but nonetheless, this would be my answer here, right? All right, let's try some more here. Okay, I got my absolute value. I know I'm going to need to get that alone. If I get him alone, then I'll remove him. So the 8, he's got to go. That's keeping him from being isolated on this side. So I'm going to subtract 8 from both sides. That means the absolute value of 3x plus 2 is equal to 4 minus 8 is negative 4. Okay. Now, again, the absolute value is going to take whatever number is inside and turn it into a positive number, or at the least 0. So what x could I possibly put in here that would produce a negative output of an absolute value? Nothing. So if I solve this right here, right, if I solve this, right, in my mind, the red flag should be going up saying, wait a minute, this can't happen. So what x's could make this happen? Nothing. So here I could just go ahead and stop and say no solutions, right? Now, if you're in machine mode and you're like, all right, I got the absolute value alone, now I'm ready to split this, and you say 3x plus 2 is equal to the positive version, and 3x plus 2 is equal to the negative version, and then you go about solving it, you're going to get these answers, right? You're going to solve them down, you're going to get some answers. Do we need to check them? technically no, but you just bypassed the failsafe here of our logical statement, and you just came down here and made these numbers. If you actually plug them in, you would see that it wouldn't work, right? Because we know that the absolute value, even if this is a negative number, right? Negative 4, for instance, times 3 is negative 12. Negative 12 plus 2 is negative 10, but then the absolute value of negative 10 is going to be positive. So even if I'm able to produce a 4 here, the absolute value is going to turn it into a positive 4, which is not a negative 4. So if you're going through the motions, like I said, and you get these answers, those aren't right. Because we technically don't need to check them if we can kind of see what's supposed to happen and what can't happen. Okay? So once we see this, we're done. We can just stop. Right? Don't proceed and get numbers. Okay? All right, let's try this one. So again, I got an absolute value. I need him alone. Once I get him alone, I can split them into all possibilities. So this 2 is attached to the absolute value. I'm going to move the 3 first so we can add. Right? So we got the 2, x minus 1, negative 3, and 3 is 0. I mean, that's fine. I don't really care what's over here. I still want to get rid of this 2. This is multiplication, so I can just divide both sides by 2, right? So that's going to leave me with the x minus 1. 0 divided by 2 is 0. Now, I mean, 0 isn't negative. I can make the absolute value equal to 0, right? That's possible. In terms of what we were doing and splitting it into the positive and negative version of this, I mean, there's no positive 0 and negative 0. There's just 0. So the only way to make this happen would be to take x minus 1 and set it equal to 0. Then we can add 1 to both sides, and x equals 1. And since 0 is a possible outcome, that would be our only answer there, right? Okay? So 0 is fine, negatives not good, positives are fine as well. All right, let's try this one. So we got some other things going on here, but that's not our focus. The absolute value is our focus. So we're going to try to remove this absolute value first. He's already isolated, which is good. So that means I can split them. I can say the expression inside is either equal to the positive version of this, right? Or the expression inside, is equal to the negative version of this. So when it was just a number, then it was the positive number or the negative number. Now, given an x, it's going to reduce down, so we'll get something out of it, right? But now we're just going to solve these down. I mean, I don't need the plus here and the parentheses, right? This one, the parentheses, is necessary because I would have to distribute, right? But I'm just going to solve these down individually, right? So I'm going to move the x over here. I'm going to subtract the 2. So 7 minus 2 is 5. 4x minus x is 3x, right? And if I divide by 3, x is equal to 5 over 3. Okay, I'm going to leave him there for now. Okay, over here, I'm just going to turn the x's positive, so I'm going to add the 4x to both sides and subtract the 7 from both sides, right? That'll move the 7 over here. So I have 5x's, right, because these cancel. Negative 2 and negative 7 make negative 9. And then if I divide by 5, I get x is negative 9 over 5. So not fun numbers, but we need to be concerned because x is a variable. X can be anything, but the output of the absolute value should produce a positive number. So what we want to check for is if we plug in x into this right side, if it makes this side negative, then the absolute value can't produce that number, right? Now, I mean, if you think about it, 5/3 times 4 is positive, plus 2 is positive, so 5/3 is good, right? 5/3 works here. Now, negative 9 over 5 is going to be multiplied by 4 and then added to 2, right? So Let's check that one. So negative 9 over 5 plus 2. So as long as this guy is a number bigger than 2, because he's negative, then that's all that matters. So 4 times 9 is what? Negative 36 over 5? I mean, 10 over 5 is negative 2, so he's definitely bigger than 2, so he's going to be negative, which means we can't have him because the absolute value is going to be equal to a negative number, and that can't happen. Right? So we only got one answer there, even though there was 2 feasible answers. That's an extraneous solution. Our math, our algebra worked it out, but it doesn't actually work, right? Okay, let's try this one. So same idea. I have an absolute value. I want to break him apart. He's already isolated, so I can say the thing inside the absolute value is either equal to the positive version. I'm just going to write the expression. Or the thing inside is equal to the negative version. Right? And then I'm going to solve these individually. Now, I don't really want to work with fractions, so what we can do is we can multiply everything by 3. And as long as I distribute here, then I won't have fractions anymore. So x times 3 is 3x. Negative 3 times 3 is negative 9. 1/3 times 3 is just 1. That's why I chose to multiply by 3. And negative 1 times 3 makes negative 3. So now let's get these x's alone. I'm going to move them all to the left. That means I'm going to add the 9 to the right. So 3x minus x is 2x. Right? Negative 3 plus 9 is 6. And when I divide by 2, I get x equals 3. Right? Over here, I need to distribute this negative. Right? Again, I don't want the third, so I'm going to multiply everything by 3. Right? I don't really care about the negative, so if you want to multiply by negative 3, I mean, that's a choice. So I just got to go to all of these. So 3 times x, negative 3 times 3. The 3's will cancel, so I'll be left with just negative x. That's fine. 3 times 1 is 3. Right? I'm going to, again, move them all to the same side to make positive x's. So I'm going to move this x over here, and I'm going to add the 9 over. Right? That way these cancel. So what do we got? 4x's equals 9 and 3 is what? 12? So when we divide by 4, x is equal to 3 again. So, I mean, they got the same number. I mean, that's fine. Right? But I still need to check to make sure it's not going to be negative. So 3 times a third is just 1, and 1 minus 1 is 0. But the output of an absolute value can equal 0. So, I mean, there's not 2 answers. There's just 1. X equals 3 is the only one, and it does work, right? Okay. All right, let's try one more. Right? Let's try one more. Okay. Okay, so we got 2 absolute values. So let's think about how this works, right? I'm going to talk through it, and then we'll sort this out. So technically, each of these can equal the positive or negative version of the other side, right? So if when we had this guy is equal to the positive or negative version of this, and this guy is equal to the positive or negative version of that one. So let's sort it out, and then we'll kind of talk through it. So I'm going to start off with the left side is either equal to the positive of this, or the left side is equal to the negative of this, right? Or we can say that this right side is either equal to the positive version or the negative version of this other side. You see what I mean? Oops, positive 2. But let's look at this. I mean, this plus is not necessary. Same thing with this plus is not necessary. So these two are actually the same equation. So I don't need to solve them both because they're the same. So if I solve this one, I'll get the same answer as this guy. Now this one, if I wanted to, multiply or divide both sides by -1, in this case I'm going to multiply both sides by -1. I think it'll be easier to see. if I multiply both sides by -1, then I have the positive version of the x plus 2, and then the negative version of this guy. So again, these two are again the same. So why do I need to solve them both down? I don't. So there's only going to be 2 unique solutions, even though there's 4 kind of ways to approach this. So when we see these, I'm just going to do it the same way we normally do. A lot of times we see the absolute value on the left, so I'm going to take the left guy and say he's equal to the positive version of the right, and take the left guy and say he's equal to the negative version of the right. And then we'll solve them down. Now if I subtract x from both sides, I get 2 equals -6. 2 does not equal -6. Since the x is canceled, there's no way to make this work, right? So that's fine. This guy has no solutions. This one can be solved, right? If I distribute the negative, then we have x plus 2 equals this. I'm going to move the x's over here to make them positive. Subtract the 2 over here. So I have 2 x's equaling 6 minus 2 is 4. And if I divide by 2, I get x equals 2. Right? Now, since x's are on both sides with absolute values, I mean, it might not be a bad one to just check these, right? So I'm just going to check it real quick. So 2, right, because x is 2. 2 plus 2 equals 2 minus 6. 2 plus 2 is 4, correct? 2 minus 6 is -4, but the absolute value of 4 is 4, and the absolute value of -4 is 4, and that works. So 2 is the only solution because this guy had no solution, right? Because the x is canceled and 2 does not equal -6. If it was like 2 equals 2, then there'd be a whole bunch of x's that works. But that's not the case here, right? Here, 2 is the only answer to this one. So when we have these 2 absolute values, I don't need to set up all 4 possibilities. I can just pick one and do the positive and negative version of that other side, and we'll get the 2 unique solutions here. Okay?